We're recording the session today, so if you have any questions during the Q&A, please put up your hand and wait for the microphone to reach you. If you're enjoying what you hear, please tweet or Instagram using @theOGTC or hashtag #TimeToTech20. So let me introduce our speaker, Lewis Dean from Visor, and Jeff, my Decommissioning Solution Center colleague. I've been working with Lewis from Visor for several months now, and given my geeky gaming background, we found plenty to talk about. This is also why the technology that Lewis is going to talk about today is so exciting to me, and hopefully to lots of you in the room as well. So, Lewis, can you tell us a bit about yourself and Visor?
So, hi everyone, my name is Lewis Dean, I'm Managing Director of Visor. We're a specific mixed reality, virtual reality outfit based in Hull in the northeast of England. We're based there because our largest customer, Centrica, runs an onshore gas plant there, which Jeff is going to talk about a bit later. And we came from the games industry, so we came from an industry of kind of high-octane explosive action into an industry where we're trying to avoid high-octane explosive action at all costs. But really, my passion is really looking at how technologies that we developed over our career in the games industry can be applied to the workforce of the future, and how new devices, new technologies help us to make that happen. So my talk today is mostly going to be me nerding out about these technologies and hopefully getting some of you thinking about how it might apply to you.
Okay. And as I said, we've also got Jeff here today from our Decommissioning Solution Center. Jeff, can you tell us why this technology is of interest to the OGTC?
Thank you, David. Yep, so at the OGTC, we're always horizon scanning to try and see what we think the next big thing for our industry might be. We do this to help develop our Solution Center roadmaps and to target the ideas that we want to support as an organization. It didn't take too much to realize that mixed reality can offer so much at a glance: improving task efficiencies, compliance, health and safety controls, and probably more importantly, retaining industry knowledge as people move onwards and outwards through their career. We can hold on to that knowledge through the use of these systems. So as I say, mixed reality touches on many of our OGTC roadmaps, and therefore it is a technology that we absolutely want to be involved with.
Okay. Thanks. Jeff will come back at the end of Lewis's talk, tell us a little bit more about the project that we're starting with Visor, and also tell you about an exciting opportunity that we got where we need your help. So, Lewis, you ready?
Yep.
Your 20 minutes starts now.
Grab this, which is quite an important prop. So, the talk is entitled Playing the Game. And my theory here is that we talk about games technologies and technologies from other industries that are involved in what we call mixed reality or spatial computing. Has anybody seen or used one of these before, just by show of hands? At least one person's used it before because I did the demo earlier. So this is called a mixed reality headset, for those of you who haven't seen it. It tracks a user as they move around their environment, and it uses special lenses to overlay digital content onto the real world in a very compelling manner. And if there's any time that any of you want to come and see a demo, you're all welcome to come visit us in Hull and go through this technology if you're new to it. But there's an issue with this, is that actually this problem is extremely difficult from a technological perspective. The technologies and processes involved in tracking a user accurately in their environment, recognizing objects in that environment, and then providing a compelling connected experience to that user are non-trivial technological problems. And this industry is one that struggles with technological adoption, not because it's not innovative, but because there's an enormous amount of process and safety processes involved in adopting technologies in general. And one of the other problems is that oil and gas companies in particular, that we've been told by any case, struggle to acquire and retain technological individuals who have the skills and capabilities to adopt these technologies effectively. And sort of what technologies am I talking about? So it's quite easy for me to say, oh, there's some hard technology in here, but I want to talk about three particular problems that these solve effortlessly, and then how the fact that we've solved these problems unlocks a new future for our workforce. So the first one is localization and mapping. So that's the concept of, if I have a large facility, where am I? And often, if you're using a device like this and you want to know to turn a particular switch or press a particular button, you need to know down to the millimeter where you are in a site that may be several hectares and may be an extremely geometrically intense environment. The second one is this idea of spatial perception. So once I know where I am, I need to have some level of intelligence around how I see my world. If I'm a computer, I need to have an almost human level of understanding. We take for granted that we can classify objects on the fly. I can look over there and see there's a cup on the table. I don't even think about that being a mentally intense exercise. But for a computer, this is a very difficult problem. And so not only do we have to know where we are, we have to know what's around us in the environment where we are. And the third one that I kind of find really interesting, this is one that isn't touched on as much when people give talks on this subject, is this idea of multi-user interaction in shared environments. There's no point kind of us tunneling away into a singular data view of the world. That's not how the world works. And it's one of the issues with adopting VR in the industry in general is that the world of work is not a singular experience, it's collaborative, and you collaborate between people and computer systems on a daily basis when you work. And any system that needs to do this needs to be able to do that as efficiently as the interpersonal communication on a plant. So these are non-trivial problems to solve, but luckily we've got some places that we can look where some significant work has been done in the fields already. So the provider of the spatial localization and mapping technology is actually the robotics industry. So the computer scientists have been trying to solve for years robots being able to have a spatial understanding of where they are in a particular environment and be able to reason around their location. And actually this headset's quite interesting because on the front is a set of cameras, and it uses those cameras, and you'll sort of see they're sort of similar to the ones on this Boston Dynamics Spot robot dog here. It uses those cameras to take a real-time laser scan of the environment and then compares that laser scan against an existing laser scanning database, and that's how it does this localization, which is really interesting. The second one is that a lot of work has been done onto AI perception technology already, and we can take those perception technologies and build them into a head-mounted format to unlock new capabilities. And that will help drive forward this idea of kind of the reasoning machine that not only knows where it is, but can see a valve that's stuck open or a door that hasn't been closed. One of the examples that Microsoft uses security cameras doing compliance training. So they'll watch workers on site, and if they take the helmet off, they get a text, say, hey, put your helmet back on. So, it's a sort of a quite scary future, and there's definitely lots of things we need to do to manage the ethical side of that. But the actual technological application can be really powerful. And then the third one that I'm actually from is this idea of, where can we bring up an example of a large number of connected people doing a complicated task together, communicating between departments and using a high degree of efficiency. And actually you can look at any competitive multiplayer online game. And in there you can find systems and processes that help with real-time collaborative work. And you kind of go for the maximum efficiency of your workforce in this scenario, because if you are not performing competitively, you lose. And actually there are huge amounts of learnings done over the last 25 years in the video games industry about how you make groups of people work effectively together towards a common goal. And I'm really keen to see some of these technologies make their way into the workplace. And we're essentially solving the same goal, except instead of winning a video game, we're maintaining a gas plant. So robotics industry, where I am, this particular problem. So you can see here this concept of the machine's view of the world, and this is how it works. So as you move around with the headset takes this very coarse sort of laser scanned image of the room, and it uses the particular chunks that it sees to look into a map and discover its location. So from an oil and gas perspective, we're actually really technologically rich in this industry because we laser scan our facilities quite often. I've yet to meet an operator who don't have some kind of laser scanning survey capability. So this technology is particularly applicable to plants because we already have this data set that's been built for us, and it's used to manage our BIM models and our Revit files that we use to maintain and operate the plant on a daily basis. And this is an example of how the computer sort of looks out into the world, and it looks for kind of sharp edges in the image and reasons about whether or not those are points in the point cloud. And it'll go off and find them in the image. And that's what the Boston Dynamics Spot dog does. So when you see it kind of walk up to a door and open it, there's a huge amount of computing work is going around reasoning it into that particular place. So it knows that the door is in front of it, it knows what height it's at. And you can see this in the demo that we've done at the back. There's a very high degree of precision of this localization. And that localization, because of the way that it works, can scale, particularly in this industry, because as I said, we have a rich data set over a huge area. So our kind of target facility where we're doing a pilot program is several hectares, and we can locate users in real time down to several centimeters inside of that volume, which is quite a good capability. And then you can unlock all sorts of things on top of that. So AI. So moving on to this idea of machine perception. So I know where I am, but I need to know what's going on. And there's a little kind of adage that I like to think about when I talk about technology. So I've got this idea that silicon coprocessors are key. And I always think of the invention of new silicon coprocessors as an indicator of a new wave of computing on their way. So the last time we had a dedicated coprocessor developed was the graphics card. And now people don't think twice about 3D graphics being a native capability of computers, but there was a time when that was impossible. You could not render CAD data on a desktop workstation. It was not possible. And the industry developed specific coprocessors to be able to process that particular kind of data natively. And that's important because with co-processors, it allows us to unlock real-time capabilities. So this is a visual recognition algorithm called YOLO, which I like. I don't know who came up with that. It's some academic. It actually stands for You Only Look Once. And it essentially means that the computer can scan at an incredible speed through a video feed and pick out particular hierarchical items that it's been chosen to detect. And what I kind of like about this is it does this in a very human manner, and we'll have to catch the video in the right phase. It's a bird, kite, now it's a lamppost. And it kind of has a guess until it refines its understanding in the same way that we do. And you can do that on this headset. So you can have somebody turn up in an environment, you know it's a plant room, but it might have been trained to spot degraded valves and good valves. It may be able to classify between things that need replacing and things don't. So because we have dedicated co-processors, and there's a silicon co-processor specifically dedicated to AI perception in this headset, we're able to do this with good battery life without consuming huge amounts of compute resources in real time at the point of consumption instead of having to talk to the cloud. So in an operation and maintenance environment where we need real-time feedback and where the quality of data is very important, but we are compute limited because we might not have great connectivity or we might be on a rig, we need to be able to use this on the device. So we've currently got stacked up, where am I, what am I looking at, and we can now move on to the multi-user collaboration. And I kind of like this clip from a video game. So this is a video game that I play at the weekends. My girlfriend says that we should be going out or something, but no, I'm not. So for me, this is a 300-person multiplayer battle simulator. But if you look closely at what's happening here, we've got vehicular assets, robotic assets, command assets, air assets, ground assets, and they all have to communicate with each other, and they all have individual roles in the system. And they have to have this kind of knit together operation between them, because the team that doesn't do this right loses. And if you actually think about it, the computer system that runs a game, because it's very data rich, it receives positional information and contextual information about every player, it's able to run the rule set of the game and determine who wins and who loses. And it's able to do that because it has this broad data vision. But actually, if we think about it, this headset is reasoning about where it is, and it's reasoning about what it sees, and it's reasoning about what happens. So there's no reason why in that kind of data-rich multi-user environment, you can't begin to build game rules around the world of work. If I'm a maintenance engineer and I walk past a valve that it knows needs inspecting, I'll be prompted to take a photograph of it. And you can start to build very complicated procedures based on this kind of technology, which has been around for years, because you're starting to take the sensors and take the equipment into the workplace. And that's the really exciting thing for me, is that we want to take what makes this really good and use it to transform the way people work in what have been traditionally very paper-based and data-based industries. This is a well-solved in video game problems. The reason why this is the largest entertainment market in the world. And there are, I kind of see from my experience, it's swathes of technology that could help other industries, and they aren't adopted. So I'm particularly passionate about us bringing this technology to the workforce. And the problem is, we go back to my existing point, though. This is difficult. If you want to do the SLAM problem, you have to be a mathematician. You want to do the AI thing, you have to be a data analyst. You want to do the networking thing, you have to be a network architect, and you have to understand connectivity and services. And those are not skills that operators can pick up as part of their IT team and use. So we've been working for the last 2 years on something that I'm very passionate about, and that's a tool set. So we've been building a technology that abstracts a lot of these concepts, and we've been producing individual tools to attack the different facets of the problem. So down here we've got the visual data database. So this stores 3D assets and allows us to reason about what things look like, and it allows us to reason about recognizing those assets in a particular environment. Here we have called the schema editor, and this is for reasoning about what data exists in this spatial operation. So as I'm out on the plant, what does my remote model component look like, and what data do I need to have about it? So this is not just a data hierarchical database, it's a spatial hierarchical database. I know where it is, I know what data it's comprised of, and I know what it physically looks like, so I can start to build these complicated models. And then we start to do sort of interesting front-end things. So one of the first examples is this. We've got a fully kind of digital twin-enabled plant demonstrator at the back there that we can do all this guided O&M on. We have some tools that calls back into. And we're also producing kind of this sort of meeting oversight program where you can stand in a control room, pull up a 3D model of the plant, and have a look at all the workers moving around in real time and get a really kind of rich data view of the plant and how it's working. And what we're trying to do over the next kind of 12 months is take this out of the lab. So in the previous 12 months, we ran some small pilots with an energy operator. We're now looking to do this on a much larger scale to understand how, as an industry, you then take this technology and put it into the workplace, because there's all sorts of compliance and regulation stuff that we need to overcome. We can have a good look at this actually working. So, you know, the AI system, the game manager, if you like, detects a fault on the site and dispatches a mission to the engineer. So the engineer is guided through the process step by step. And something really interesting happens. The minute that he turns the switch, the system takes the control system and makes the instructions to the engineer. And not having to manipulate it, anything to do with the system. So really, the way that this makes it work is and that's really what we're looking at kind of taking out to site over the next kind of 6 to 12 months and running a number of pilots with. But what we're really interested in doing is finding problems now. And I've given you kind of a tool set of ideas of how this technology might apply to the industry and talking to particular people about particular problems that we think it might be able to solve. So we're in an early stage with this, but we do see this as being a kind of seismic shift in the way that this sort of work is done and the applications of these technologies and how they help shift the perception of this kind of technology in the workplace. But yes, that's my talk. Thank you very much.
Thank you. Just before we move on to Q&A, we're going to get Jeff just to...
Well, Jeff has an important announcement.
Well, he's going to mention a bit about the project that we're going to be running next year. So.
Thank you, David. Thank you, Lewis. So yes, over the last few months, the Decommissioning and the Digital Solution Centre teams here at the OGTC have been working together with Lewis and his team at Visa to pull together a project proposal. So we're anticipating a kick-off in January next year, and when that kick-off does happen, we believe it will be the biggest mixed reality project of its type in Europe. So we're really quite excited about that. The project is going to be made up of, or at the end of the project, we're hoping to be able to complete 10 different maintenance and operational tasks through the deployment of the HoloLens. So the frontline worker will be able to complete 10 different tasks using the HoloLens as its aid. But why is it so important to all of us? And really it's the bit of what comes next. Because it will demonstrate some of the mixed reality capability in our industry. But it will help to demonstrate, arguably, it will then be able to show our industry where we can go next with it and what kind of applications and solutions we can take next into our industry. And that's where I really want your help and for you all to get involved. So at the same time as launching the project, we're also going to be launching a mixed reality technology steering group. And at the moment it's an open invitation for everyone in industry. And we want to get as big a spread as we possibly can from as many different organisations as we can. Because we believe this technology can touch in so many areas. And what we want to do is to start developing a roadmap and a strategy to make sure that we develop this technology in the best way possible, so that when ready, the different parts of the technology integrate with our systems, with our setup in the best way it possibly can and as seamless way as it possibly can. So when I say that, I mean system integrations, workflows, formats, etc. And we also hope it will then guide the strategy for what needs to be developed next. So yes, we're doing maintenance and operational tasks just now, but there's so much more: commissioning, construction, integrity, inspection, robots. There's so much that we can do with it, but we want to make sure that we decide what needs to be done next and when in a way that kind of works best for everyone and the organisations involved. So after this, I'm going to be up in the reception area for a while. Please come and speak to me if you're interested or you think it's something that your organisation might be interested in, or if one of your colleagues would like to be interested in. I'll give you my business card, and then early next year we'll get in touch for that first meeting, and then we'll start to channel down exactly what that group needs to look like and where we go from there. And I see that as a lot of kind of splinter groups that come off that, lots of little workshops and things like that, and we can move on from there. But it's to make sure that this technology is adopted in the best way possible for our industry.
it's kind of worth me pointing out as well that although we're running a project next year on some software that we've built, it's our intention for this to be an open platform. So we're not going to go away and build some software that we own and then we go and sell it to everyone. We want to empower both operator organisations to use this platform in a tailored specific way to them, but also for sort of other clients of those operators to be able to use this technology to problem solve in that industry. So we'll be releasing again the toolkit for doing this kind of work. We don't intend to be the sole and only provider of this technology to the industry. We're just not big enough, and I don't think we could be. So really we're looking to build a kind of collaborative approach both between operators who have a mission to do and providers who perhaps have a specific vertical that they address. So we had some nice conversations earlier about compliance training and how that's done. So hopefully looking to see how that technology can apply to that scenario. But there are many other scenarios, not necessarily covered by the project, but will be covered by the technology that we'd love for the steering group to kind of bring out that would work for us to attack.
Okay. Thanks, Lewis. Thanks, Jeff. Sorry. Let's get straight into the Q&A because I think there's some questions we're ready for.
Hi, thank you very much for such a lovely presentation. Kind of have a challenge for that particular technology. Imagine that you are in a basement and there is no coverage, there is no possibility to understand where I am at a particular minute, but because you can build a database of a room, so it's not that you can recognize the valve, for instance, but you know exactly what is the position of that particular valve within the environment. Would there be a possibility to have an initial coordinate and track what you are doing in order to get to a particular place if you don't have any other mean of understanding where you are? Would it be a possibility to track that?
That's exactly what happens.
Right.
So the way that the system works, not to dig too much into the technology, but simultaneous location mapping then reckons from the last known position. So if you know you're at the top of the stairs and you know that's a known location, you then will record as you head down the stairs this new environment that it's never seen before. And then when you head back up the stairs, it will recognise the top of the stairs again and perform something called a loop closure and bring that unconnected area into the database. And then from then on, anybody else will be able to reason against that spatial environment. So the technology supports entering both an environment with no connectivity, but also an environment that's never been seen before. So the database grows organically as users move into areas that aren't covered by the database. So you can kind of bring in areas that aren't already in the system. But also you're not limited by connectivity in that manner, or these are infrared, so not even by lighting conditions. But you can use these in the dark and with no connection and still have the simultaneous location mapping capability. And that's actually, to knit all the slides together, that's down to the code processor on here, which can run the system locally, as opposed to needing to connection to a server and do it effectively.
Okay, one more thing. If you're showing what the operator should do in order to sort out the problem, would there be a possibility as well to understand what it is the time frame involved in that particular, sometimes you need to press one thing and less than 2 seconds before, after you need to do another thing or something. Would there be a possibility to integrate all that within the application?
Yeah, so I don't know if there's actually, step back through, no, that's the wrong. So there's these kind of data sheets cover multiple scenarios, and you can write data sheets for the O&M processes. So the O&M process is driven by a logical data sheet. You can add in any number of conditions. So you can say this button has to be pressed, but the pressure in this pipe also has to be 0, and this must be done within 30 seconds of the first button being pressed. So you can chain together these multiple events, and that's what games technology is very good at. Games are very good at scripted sequences, and we want to bring scripted sequences into the workplace and call them work packs. But realistically, they are sort of guided missions, and everyone's seen a bit of the game. We have to get through the door within 30 seconds or that. So that's very much within the realm.
Okay. Another question?
Hi, it's Alan Smith from Tooktown. Question about the platform and the connection. What do you need in terms of IT connectivity for this to work? Is it Wi-Fi, 4G?
You can connect it with anything that will provide a round-trip latency of around 40 milliseconds. These have Wi-Fi built in, but there's no reason why you can't tether that to a 4G or 5G enabled 8X phone, for example. So actually, the deployment that we're going to be doing, the operators have 8X enabled phones anyway, and we'll be tethering to those for the connectivity. You can also produce specific scenarios where, for a particular operator, we could use any other number of network technologies. So the connectivity layer that the platform uses isn't bound into the thing. So you could run this on normal RAN or any kind of emerging IT technology as well if you want. It's not very bandwidth heavy. It just is latency sensitive. I mean, the pilot that we're doing is run on a private 5G network, for example. That's how we're doing that connectivity. But there are any number of approaches to different connectivity scenarios.
Yeah, because the issue we're finding on in Franklin, we've got excellent 4G coverage outside outside the hull. When we go inside the hull, we switch to the welfare Wi-Fi. We lose connection, then it reestablishes.
Yep.
But then the welfare Wi-Fi is not as good as outside. And specifically, if the OEM closes his office door, he switches off the Wi-Fi for us on our industrial network.
Yeah.
So I've got challenges with that, and I'm trying to get 4G boosters inside. But it's just, I was asking a question because the proof of concept document we're working on for Elgin.
Yeah.
It's
worth
what I need to think about.
Yeah, absolutely. And that's sort of the meat of it. The whole reason we're running this kind of bigger pilot program as well is to uncover and write documents for those particular scenarios. So we say, actually, we've got a report on how you do this sort of deployment.
Hi, Kuljit Singh from Rapsol Sonopec. What was your biggest challenge in implementing this solution in Centrica, and how painful was your adoption process?
I'm not sure if I could say that working with Centrica was painful. I wouldn't have said it the same problem. But I understand exactly what you mean. I mean, these kind of technological adoption problems are often as much organisational as they are technological. And helping to kind of work with the O&M workforce in helping them understand the technology and the applications that it have. And actually one of the really interesting pieces of fallout from that, if you like, is the reason that we're running an onshore demo is we don't want to attack the technical aspects of running offshore alongside the organisational aspects of onboarding their O&M team into the process, so we're doing them one thing at a time. So we want to get the organisation loving the technology first and then look, okay, well let's take it offshore and have the additional pieces of it. But yeah, it's absolutely, there's definitely a defined amount of user skepticism about this kind of technology and it coming in and replacing processes. But it's good change management. That's true of any kind of technology you try to bring into an organisation. It's probably accentuated by the fact that this is a bit more space age than asking somebody who does a pay performance to use an iPad. This has got quite a few more technological barriers into it. And in fact, my favourite one was running a demonstration with a man who claimed to be allergic to Wi-Fi. So that was a really interesting thing to try and overcome. But yeah, it's the same sort of organisational pushback from any kind of technology adoption. But actually, I will say, and I don't have to say this, that I found Centrica to be particularly adept in working with us to develop the technology strategy, and our solution to that was to make sure that we had the right stakeholders in the business who knew how to drive those kind of change programs to make that happen. If that helps.
Yeah.
Any more questions? Oh, okay.
Hi, I'm Fure Ståldal, Chief Digital Officer at Tampnet. So I'm very happy that people use connectivity and you love these kind of solutions that drives connectivity. In terms of your business model, how do you see your business model and can you elaborate a little bit more on that?
Yeah, so from a business model point of view, it's quite simple. We mark up with an IP markup and an operational markup the use of compute assets. So every single node that's in the field, be it someone with a headset on, or be it a robot, or be it a server that's running the system, consumes a certain amount of compute resources, and we sort of define that out as being about £50 per month per node. So for each person in the field who uses this system, they pay a licensing fee. And that licensing fee covers the cost of the infrastructure that runs the program underneath, and we have a very sort of flat rate for security requirements and that kind of thing. So if you have specific security requirements, we deploy all of this in Microsoft Cloud, and we've got resources in the UK secure data centres, the European secure data centres, the American data centres. So we often find the problem with that is that you have to comply to the organisation's data policy if you're going to sell SaaS software like that. But yeah, it's a flat rate, it's £50 a month per person, and then you can use it. That rate doesn't include the cost of deployment, so there's often some consultancy in understanding how to put this out on the plant and prepare the the system, but then once it's up and running, it scales sort of linearly and then kind of goes like that with the more that you buy. But those are the business model we're currently running. And that's open. That system's open. So I was talking quite passionately about client organisations who take this technology and build solutions on it. They can then mark that fee up and white label it as their own platform because this kind of works. So that's how we'll achieve scale through that. We want to take the. I mean, we've spent in the region of a few £1 million on the R&D for this. We don't want 4 or 5 person technology outfits who are doing this consulting work to have to make that outlay. So we sell them that for £50 a month, and then they mark up that with their own costs to deploy it. And we see that being a nice, fair way of running an open business model like this, but also being able to pay for the resources and the R&D that are in the platform.
And the IP itself is I mean, in the code and so that's open source, I believe?
Some of it's open source and some of it isn't. So things like the data layers and the security layers we keep closed source, but the actual applications that are developed on this platform are available to open source. And when we work with an operator, for example, and develop something specific, they own all of the code for that and they own the application. So.
I guess there is an opportunity for that, but can you track what the operator is doing? Say that you need to tight a particular screw or something with a particular torque. Can you get some feedback about what should be done and what has been done in order to, train a little bit more to the operator, or just tracking what can be improved?
Yeah, so there's although the presentation is quite heavy on sort of headsets and people, there's a huge multitude of devices and connected systems that could be built into these maintenance procedures. So some of the things we talked about earlier, the control system might use pressure sensors to validate that valves have been closed. But you can also equally, you can get CAN bus connected torque wrenches that they use in the manufacturing industry. And they provide an IoT, I think they have an IoT interface on them which measures the torque. So if you had something that was, for example, trying to measure that bolts are torqued in the correct manner, you could have a device talk back to the HoloLens, and the HoloLens would send the data with the pose and position back to the system. So you can create a sort of web of connected devices that help build this data model. And actually, one of the key things to do when we first start the process is identify the data modeling of particular tasks and where we can source those kinds of data from, whether that be AI recognition, so we recognise that a door is closed or a hat is on, or we actually look at further integration with control systems and then different kinds of sensors on site. And that's the reason that the connectivity is so open as well, because we may need to talk to 4 or 5 different protocols to achieve that data model, and we can do that with ease.
What about the learning process? Because sometimes you probably say, well, if this particular thing happens, it should be because that particular device has been triggered or whatever, but probably we misunderstand that there could be other reasons behind that. So is there any way of learning, learning from doing?
Yeah, I mean, you can record what happens, which is a new technology. Because at the moment, you don't have a real-time data feed of when an incident occurred, for example. So you can actually look back and see what the data feeds were doing when that incident happened if you have something go wrong. But also something that's quite interesting to me is you can also then expand outside of the realm of the programming of the system. So you might have the first part of the maintenance procedure might be to do some diagnostics, and one of the steps can just say, if this doesn't line up, press this video call button and we'll call the site manager who knows how this works, and you can have a video chat, or he'll bring in a remote expert who built that piece of equipment, for example. So you can expand the knowledge base out of the system beyond the sort of strict logical rules that it runs on.
Yeah, but sometimes you don't know that's what because you can assist the operator in but it's more about learning. Yes.
Sorry, if we can just make it a very quick question because we have to wind up.
A yes or a no question then?
Yes.
So it's maybe one for the OGTC. It's Alex Robertson from Petrofac. As these new technologies come in, and this is a great presentation, really, really good. But as these new technologies come in, we need to choose to, as organizations, choose to adopt one technology or another technology. And the risk is if we choose one, is another competitor going to come in and buy those companies out? And then there is a real kind of barrier for adoption for us internally in terms of understanding what the risk profile is for these emerging technologies. You've got a view on that?
I think that's quite an interesting risk from my point of view. I mean, I've sort of seen this happen, especially in the American petrochem market. This is happening to companies like mine, where they're being bought into exclusivity agreements with particular operators, and then if your plant doesn't run that system, then you can't use it. From my point of view, I'm very passionate about open software to a point. Some of it has to be closed for security reasons, but we like things to, we like the operators to own the software that they're using. They own their maintenance procedures. And we want to kind of get ourselves into a position where we can have a certain level of guarantee that the work done in the system will always be accessible to an operator who adopts it. But it is a difficult, I think that's more of an industry challenge than a challenge that we can address directly, because it can be very difficult when you've got a staff of only people you need to pay for to turn down an acquisition offer. And I don't really know how as an industry, or maybe as a country, we protect our industry from that kind of activity.
From our point of view, we're here to further the development of the technology, and that's what we want the steering group to do, but we want to make sure that it hits the industry in the right way. But when that happens, then that needs to be a consideration that we make. Sorry. Did everyone hear that?
Okay. Okay, thank you very much for your questions. Just have to say now thank you to Lewis for his presentation.